Figure 5.6, Compound Interest Calculations with the For statement. Now, in this example, we're just going to be introducing the C++ for repetition statement, and for the purpose of demonstrating it, we've got a little compound interest calculation program, and what we'd like to do is run that just to show you the output. Here you can see we have two columns of output where we're showing you 10 years worth of compound interest and the amount on deposit at the end of each year. And what we did is we started with a principal amount, in this case of $1,000, and we have 5% interest. So let's take a look at the source code for this one. We are also introducing another new formatting feature here, the setW stream manipulator. SetW is for setting a field width, and by default, when you display something in a field of characters, it displays in that field right justified. So we'll use that to produce the right justified second column, and even actually the right justified first column as well, so that we can display all of the year values right justified and all of the amounts on deposit right justified, and thus line up the decimal points in our dollar amounts. We're also introducing from the C math header file the POW function, which allows you to raise a value to a power, and it receives two double arguments to do that. So let's take a look at our simple main program here. We declare a variable called amount of type double. That will be the amount on deposit at the end of each year. Our initial principal is $1,000, and we are initializing that directly in the declaration of the variable, so that both creates the variable and initializes it immediately. And we're also setting our interest rate to 0.05 to represent 5%. At line 22, we output the headings for our two columns of output, the year heading, followed by the setW stream manipulator with an argument of 21, which says that the very next item that we output should be right justified in a field of 21 characters. And if I remember correctly, amount on deposit has about 15 characters in it, so what we're going to do is have 6 spaces followed by the string amount on deposit. Then we'll output an endl stream manipulator, which will insert a new line into the output stream to move to the next line and force the headings to appear immediately. The next thing we do is we set up the floating point formatting for the rest of the program by outputting the fixed stream manipulator and the set precision stream manipulator with a value of 2 as an argument, saying all floating point numbers should be displayed with 2 digits to the right of the decimal point. And remember that the fixed manipulator forces the decimal point to appear, so no matter what in this program, every single dollar value will have 2 digits to the right of the decimal point. At lines 28 through 35, we have the key part of this program, which is our for repetition statement. And if you're coming to C++ from a C-based programming language, such as C, Java, C#, even JavaScript, then you'll be familiar with the syntax of the for repetition statement. Basically, it starts with the for keyword, and then in parentheses we have 3 sections to what I like to call the for header. And those sections are the declaration and initialization of the counter variable, the condition, which always appears between 2 semicolons, and then the increment of the counter variable. Now, the control variable can be declared before the for statement. However, if you declare it in the for statement header, as we're doing here, saying that year is an int, then the scope of that variable in C++ is just the for statement, which means that when we get to line 36 and beyond in this program, the variable year no longer exists. The initialization of the variable year to 1 is also incorporated into the declaration in this first section here. So this is what we call the initialization section of the for statement header. Then, as long as year is less than or equal to 10, we'll keep iterating. And the way the for loop works is that when you first enter the loop, it does the initialization section, then it checks the condition, then it executes the body of the statement, and after the body executes, it performs the increment of the control variable. The nice thing, though, about the for is that everything you need to know about the counter-controlled repetition is shown to you right there concisely in one line. And by the way, common programming error is to either not include the semicolons or to not have both semicolons. These two semicolons are required. If there's nothing in the initialization section, it would typically mean that you've created that variable up above the for loop and initialized it before you got to the loop. If you provide nothing between the semicolons, then you're creating what we call an infinite loop, because the condition is always assumed to be true in that case. And separately, if your increment section is left empty, that would mean that you're performing the increment somehow in the body of the loop. Now, at line 31, we have our calculation that's going to determine the amount on the deposit at the end of each year, and to do that we're going to multiply the principal by the quantity 1 plus the interest rate raised to the year power. So 1.0 plus 0.05 is going to be 1.05, and we're going to raise that to the year power by passing it to the POW math library function. From the C math header file. And again, we included the C math header file back up here at line 12. For those of you who might be coming from the C programming language, the C math header file is actually the math.h header file from the C programming language, renamed for the purpose of C++. And in the C math version of the header file, all of the C standard library math functions are actually wrapped into what we call, again, the standard namespace. Everything in the C++ standard library, which includes everything from the C standard library, is part of the standard namespace. So again, in order to use POW in our program by just saying POW down here, we have to say that we're using it, or down at line 31 we would have to say std : POW. So we're going to perform our calculation, and then we're going to output the results. Set W with a for as an argument says that the very next value we output should be displayed in a field width of 4, right justified. If the value is smaller than 4 total characters, then there will be leading spaces. If it's larger than 4 total characters, it will simply display the entire value, and our columns won't align properly. Then we do a set W with 21 as the argument, saying that the next value should be output in a field of 21 characters, right justified, and we output the amount. And remember that we've set up the output so that all floating point numbers are going to be displayed with 2 digits to the right of the decimal point. So when amount gets output, those 2 digits to the right of the decimal point will be all the way at the far right side of this 21 character field, and that will allow all of my decimal points to align in the program output. And just to reiterate, here's the formatting being shown to you on the screen. Now, I do want to point out a concept called, with respect to these parameterized stream manipulators. We have 2 of them in this program, set W and set precision, and we call them parameterized stream manipulators because they receive arguments to perform their tasks. Now, in this case, we have 2 different types of parameterized stream manipulators, and we like to call them non-sticky and sticky. A non-sticky parameterized stream manipulator basically says that it applies only to the very next value that gets output. So, for example, set W is a non-sticky stream manipulator because all it applies to is the very next thing that we're going to output in this statement. On the other hand, set precision and fixed as well are considered to be sticky stream manipulators because from the moment that you set them, by outputting them to a cout object, they apply to all subsequent floating point values. So no matter what I do for the rest of this program, every single floating point number is going to have a decimal point, and it's going to be displayed with 2 digits to the right of the decimal point, unless I go and change the formatting at some later point in the program. So some of the stream manipulators are sticky, some of them are not. The ones that are sticky apply from the point at which they are set until they are changed at some later point in the program or until the program terminates. And the ones that are non-sticky apply just to the very next value that gets output.